Intel's Core CPU and Arc GPU work together to deliver balanced performance and power efficiency for gaming and content creation. But how do they achieve this synergy? Let's find out. First, let's talk about the Intel Core CPU. This is the brain of your PC, and it handles all the complex calculations and instructions that run your applications and games. Intel's Core CPU is based on a hybrid architecture, which means it has two types of cores: performance cores and efficient cores. Performance cores are designed to handle demanding tasks that require high speed and responsiveness, such as gaming, video editing, or 3D rendering. Efficient cores are optimized for low power consumption and background tasks, such as web browsing, email, or music streaming. By using both types of cores intelligently, Intel's Core CPU can deliver the best of both worlds: high performance when you need it, and low power consumption when you don't. But how does the Intel Core CPU know which type of core to use for each task? That's where Intel Thread Director comes in. This is a smart algorithm that monitors your system and assigns tasks to the most suitable cores based on their workload and priority. For example, if you're playing a game that requires high frame rates and smooth graphics, Intel Thread Director will allocate more performance cores to your game and less efficient cores to your background applications. This way, you can enjoy a smooth and immersive gaming experience without sacrificing battery life or system responsiveness. Now let's talk about the Intel Arc GPU. This is the eye of your PC, and it handles all the graphics processing and rendering that make your games and content look stunning and realistic. Intel's Arc GPU is based on the SE architecture, which is a scalable and flexible design that can adapt to different performance levels and form factors. Intel's Arc GPU offers several features that enhance your gaming and content creation experience, such as ray tracing. This is a technique that simulates how light behaves in the real world, creating realistic shadows, reflections, and lighting effects in your games. Intel's Arc GPU has dedicated hardware for ray tracing acceleration, which means it can handle this complex task faster and more efficiently than software-based solutions. SE Super Sampling. This is an AI-powered technology that uses machine learning to upscale low-resolution images to higher resolutions without losing quality or detail. This way, you can enjoy crisp and clear graphics even on lower-end displays or with lower game settings. SE Matrix Extensions. These are special AI engines that accelerate various content creation tasks, such as image editing, video processing, or 3D rendering. By using these engines, you can speed up your workflow and unleash your creativity without compromising quality or accuracy. AV1 Encoding. This is a new video compression standard that offers better quality and efficiency than previous formats. Intel's Arc GPU has dedicated hardware for AV1 encoding, which means it can compress and stream high-resolution videos faster and with less bandwidth consumption. But how does the Intel Arc GPU work with the Intel Core CPU to deliver balanced performance and power efficiency? That's where Intel Dynamic Power Share comes in. This is a technology that intelligently routes power between the laptop CPU and GPU based on their needs. For example, if you're playing a game that requires more graphics processing than CPU processing, Intel Dynamic Power Share will allocate more power to your GPU and less power to your CPU. This way, you can maximize your gaming performance without overheating or draining your battery. As you can see, Intel's Core CPU and Arc GPU work together to deliver balanced performance and power efficiency for gaming and content creation. By using their hybrid architecture, smart algorithms, dedicated hardware, and AI technologies, they can adapt to different scenarios and optimize your PC experience. Whether you're gaming, multitasking, or creating something incredible, Intel's Core CPU and Arc GPU give you the power to do it all. One of the main advantages of Intel's Core CPU and Arc GPU bundles is that they can support advanced features such as ray tracing, eye-enhanced graphics, adaptive sync, and variable rate shading. These features can improve the visual quality, performance, and responsiveness of your PC games and applications. Ray tracing is a technique that simulates realistic lighting effects by tracing the path of light rays in a 3D scene. It can create stunning reflections, shadows, and global illumination that make your games more immersive and realistic. Intel's Arc GPUs have dedicated hardware units called ray tracing units, RTUs, that can accelerate ray tracing calculations using the DirectX Raytracing (DXR) API. Intel also uses asynchronous ray tracing, which combines rays with similar hit shaders to ensure the RTUs are fully utilized. AI-enhanced graphics is a term that refers to using artificial intelligence (AI) algorithms to improve the image quality or performance of graphics rendering. For example, Intel's Say Super Sampling technology, SaySS, is an AI-enhanced upscaling technique that can increase the resolution of a low-resolution image while preserving the details and sharpness. SaySS can boost the frame rate and reduce the GPU load by rendering at a lower resolution and then upscaling to a higher resolution using a neural network. SaySS is optimized for Intel's Arc GPUs with the ability to take advantage of XMX AI hardware acceleration. Adaptive Sync is a feature that synchronizes the refresh rate of your monitor with the frame rate of your GPU, eliminating screen tearing and stuttering. Screen tearing occurs when the GPU sends more frames than the monitor can display, resulting in horizontal lines or splits on the screen. Stuttering occurs when the GPU sends fewer frames than the monitor can display, resulting in uneven or choppy motion. Adaptive Sync solves these problems by dynamically adjusting the monitor's refresh rate to match the GPU's frame rate, ensuring smooth and fluid gameplay. Intel's Arc GPUs support Adaptive Sync through various standards such as HDMI 2.1 VRR, DisplayPort 1.4a Adaptive Sync, and AMD FreeSync. Variable Rate Shading, VRS, is a feature that allows the GPU to vary the shading rate within a frame, meaning that different parts of the image can have different levels of detail or quality. This can improve performance by reducing the GPU workload for areas that are less important or less noticeable, such as distant objects, blurred backgrounds, or fast-moving scenes. VRS can also enhance image quality by increasing the shading rate for areas that are more important or more noticeable, such as focal points, edges, or high-contrast regions. Intel's Arc GPUs support VRS through the DirectX 12 Ultimate API, which offers two tiers of VRS functionality. Tier 1 allows per-draw call control over shading rate, while Tier 2 allows finer-grained control over shading rate within a draw call. Intel's Core CPU and Arc GPU bundles offer competitive pricing and value for PC builders who want a seamless and optimized experience. In this section, we will explain how these bundles work and why they are a great choice for your next PC build. Intel's Core CPU and Arc GPU bundles are based on extensive testing and data analysis that Intel conducted to find the best balance of gaming performance and price. Intel compared different combinations of its 12th and 13th Gen Core processors and its Arc A700 series graphics cards across over 50 games and more than 15,000 test runs. The results showed that the Intel Arc A750 and A770 GPUs usually reach peak performance when paired with a Core i5 or i7 CPU from the Alder Lake or Raptor Lake generations. These mid-range CPUs provide enough power and features to support the Arc GPUs without creating a bottleneck or wasting resources. By choosing an Intel Core CPU and Arc GPU bundle, you can benefit from several advantages. First, you can save money by getting a discounted price for both components compared to buying them separately. Second, you can get free games and apps worth up to $500 as part of Intel's incentive program. You can choose between up to 4 games and 3 apps from a selection of popular titles and software. Third, you can enjoy a seamless and optimized experience with Intel's drivers, updates, and features. For example, you can use Say Super Sampling to boost your graphics quality and performance in over 50 games. You can also rely on Intel's Game On drivers to support new games as they launch. Intel's Core CPU and Arc GPU bundles are available from dozens of retailers worldwide and from several PC makers that offer balanced build systems with an optimal CPU and GPU configuration. You can find the most affordable gaming CPU bundle for $423, whereas the cheapest PC can be obtained for $899. Whether you want to build your own PC or buy a pre-built one, you can find an Intel Core CPU and Arc GPU bundle that suits your needs and budget. In conclusion, Intel's Core CPU and Arc GPU bundles are a smart way to get a balanced and efficient PC build that delivers great gaming performance at a competitive price. By pairing an Intel Arc A750 or A770 GPU with a Core i5 or i7 CPU from the Alder Lake or Raptor Lake generations, you can get the most out of your components without compromising on quality or value. You can also take advantage of Intel's free games and apps offer, as well as its drivers, updates, and features that enhance your gaming experience. If you are looking for a new PC build that combines power, performance, and price, you should consider Intel's Core CPU and Arc GPU bundles.